This podcast is supported by Hannover Messe, your meeting place for the industrial community.
Hello everybody and welcome to a new episode of our Industrial AI podcast. My name is Robert Weber. Once a month we introduce you to an industrial AI startup. In this episode we introduce Phantasma from Berlin. The engineers focus on a reinforcement learning approach for the shop floor. Enjoy listening. My guest is Ramakrishna Nanjundaiah. Welcome to our podcast.
Hi, Robert. Thank you for having me here. It's a pleasure to be with you on the podcast.
I hope I have pronounced your name correctly, right?
Absolutely. Yeah. You're one of the few ones who got it perfectly well.
You are the founder of Phantasma Labs. Rama, please introduce yourself briefly to the listeners and explain how you came up with the name Phantasma. That sounds very interesting.
It's a very good story. The credit for this name goes to my co-founder completely. So we built Phantasma Labs by combining the technologies of simulations and virtual worlds. And Phantasma in Portuguese means something that's imaginary and virtual. So we thought this is the appropriate name to kind of, depict what we are doing at the company, just basically leveraging simulations and AI to build the solutions. That was the only reason. There was nothing else behind, coming up with this name.
Okay. Introduce yourself, what you did before Phantasma. What kind of experience do you have on AI?
Absolutely. So I have a very interesting detour into AI, rather, because I studied my bachelor's in mechanical engineering from India. And following that, I studied what's called as computational mechanics or simulation sciences from the Technical University of Munich. And it's basically in this program that I was introduced to a lot of different courses in software engineering, including AI, machine learning. And that's how I got into AI. And I got my hands dirty primarily by working on projects with industrial partners. For example, I initially started out by working with the MAN, Diesel and Turbo, a big automotive company, building AI models for them. And ever since then, I've been building AI models primarily in simulations. So I would say I'd rather have a non-computer science background, but with more application experience into AI. But I'm always fascinated by how any qualified person can use AI models to build compelling solutions for enterprises.
And you worked at Audi, right?
I worked at MAN.
MAN, okay. MAN. I thought it was Audi, but it's MAN. Okay, right. What did you learn at MAN and what is your approach now for the industrial sector?
So in MAN, the goal was to use AI models to optimize designs. As you know, MAN is a big company. They build big engines, big trucks and ship engines. And they have the challenge of, understanding how can they optimize certain aspects of the engines that go into operations. And typically, this is a very complex process because, you have a number of parameters that are based on physics, that are based on, mechanical laws. And you have to take all of these parameters into account to come up with optimal solution. And the most classical way to do this is actually to use, let's say, conventional optimization methodologies where you do a linear optimization, which normally takes couple of months to years because the number of designs that MAN has to build is immense. So the idea back then, already in 2012, was to use actually AI-based methodologies to increase the speed at which, you can optimize designs. Instead of, waiting for weeks or months to get optimal design, through AI models, we could generate new designs pretty much on a daily basis. So that is actually one of the biggest advantages of AI that we kind of saw in AI back in MAN in those days. Now, applying this to the industrial sector, the problem space is very similar, but just formulated differently. If you look at a typical factory, they have a number of different parameters they have to deal with. For instance, the staffing shortage might be an issue for them on a particular day. The materials might not come on the right time.
Energy prices,
exactly. And they being overload, offload, for example. So typically factories have to decide pretty much very dynamically than ever before. So they want to make decisions every day as to how they can improve their factory operations. And they cannot wait for, let's say, a couple of days to get the optimal solution. And that is where we brought in the AI solution to build, this, what we call as decision-making models for factories.
There are a lot of automotive use cases on your website, but you want to go to the shop floor. So you take this simulation topic from MIN and you want to do a simulation, a process planning, optimization on the shop floor. Is that the key approach?
Absolutely. So we actually initially started out by providing our solutions to the automotive markets, specifically autonomous driving markets, because they have a similar problem there. So autonomous cars, they have to decide in real-time basis as to what control measures they have to take. For example, if a person jaywalks in front of a car from nowhere, or there's a weird traffic sign that the car doesn't know, then the cars have to respond in real time. So that's the technology what we are using in the industrial sector as well, where we are helping industries to optimize operate on a real-time basis. But what is really, really unique and applicable for all the enterprise markets we're targeting is the core technology what we use. So we, unlike other solutions which use a lot of data to train AI models, we use a technology called reinforcement learning, which is basically training AI models based on simulations or virtual worlds. And that gives us immense opportunities to apply our technology from one domain to another domain. So when we move from automotive to smart factories, for example, the way we do this is by building simulations of the factories. And based on that, we train our AI models based on reinforcement learning. So the core tech is the same, just the virtual worlds we build is different.
When you talk about reinforcement learning, it's a bit of magic for many people in the industrial sector. When we talk in the podcast about that, can you explain to us how such a reinforcement project starts and what the processes look like?
Absolutely. You're absolutely right. When we pitched our idea initially to Aldi, for example, they said, "Man, this is not possible." But, we proved that this technology works. So when we mean reinforcement learning, we are very conscious about the use cases that we target through this approach. So we're not going to claim that we can do reinforcement learning for every possible use case within the factory domain. For example, predictive maintenance or forecasting of prices or demand, all these data historical data. And, we don't tackle those use cases with reinforcement learning. But what is really key, especially in the industrial domain, to apply reinforcement learning is the fact that you can only apply this technology to use cases that you can model in simulations well. A typical example of this is like assembly line. This is something that you can model in simulations very well because what machines are there, what's the process time, how much time does it take for the process to go through one machine, what's the downtime. So you have pretty much all the information to, let's say, build the simulations. And for such use cases, reinforcement learning makes a lot of sense. But for other use cases, for example, as I mentioned, forecasting or predictive maintenance, you need to collect data. You need to have a lot of information before you can, predict your approaches there.
Sure. Can you explain to us how such a reinforcement project starts? When I have a factory or a shop floor and I said, Rama, you are welcome to show me how reinforcement works. Can you explain me how the project starts and what the processes look like?
So a typical starting point of the project is like getting the data snapshot of the factory itself. So snapshot is typically basically, saying, okay, how does this factory look like? How does the assembly line look like? How many machines do they have in general? How is the staff and the operator, for example, capabilities? So this is basically data what, our customers have pretty much in one of the databases, for example, in the ERP tool, or, sometimes customers have it within the Excel sheets. So we use this base data or data snapshot to build our simulations. So we tell our customers, you just give us this base data. You just tell us, what are the KPIs you want to optimize for, whether it's optimizing for the cost of production or reaching your volume targets or, reducing the cycle time. You just let us know the KPIs you want to optimize for, and you just let us know how your factory looks like as of today. And based on this, we go ahead and we build the simulations, we train our models, and end of the day, we ship these models to our customers. And our customers, they can use these models pretty much on any kind of, interfacing tools what they have. For example, some customers, they integrate our models in the MES tools where they can just get, an optimal plan automatically coming from our AI models. Or some customers just use our technology or the product as a standalone tool. So we will have a small interface where they say, hey, today I have a reduction in staff because 10 people are sick. Now you tell me how I should relocate my staff, for example.
The customer asks the software or the application what to do now, right? That's a possibility.
Exactly. Absolutely. They can do this pretty much on a daily basis. And one consistently challenging use case in the industry, what we see here is, a lot of customers, they have varying orders or EDIs coming from their clients. So typically when they make the plan for the factories for the whole week, they assume that nothing changes. But if something changes, let's say on Tuesday, the customer would come and say, hey, we want 20% more. Or when Wednesday they say we want 30% more. Then they would want to understand, number one, if they can meet these increase in demands that's coming from their customers. And number two, if they have the enough resources to do this. And number three, if they can do this, how should the plan look? And as you can see, they cannot wait for 2 or 3 days to make this plan. And the state of the art in a lot of the industrial sector we see today is that, especially in the Mittelstand sector, is that, they use really, simple tools like Excel sheets, or sometimes, decisions are taken by gut feelings, like people are there in these factories with a lot of knowledge. So based on gut feelings, they just take decisions as to how they should plan, which is not optimal. So we believe that, there's an improvement room of about at least 30 to 40% in most of these factories through an AI-based tool like ours.
I have one more question. How do you build this simulation? Please explain me on which database you work and what kind of things you use there. What kind of tools you use there?
That's a very good question. And we use different simulation tools based on the use cases. If you're talking about optimizing processes within the factory, for example, the assembly line processes or something else, then we use process simulation tools. We build most of them in-house because we have a lot of experience with simulations from ranging from 1D to 3D simulations. So we build them in-house and we use process simulation tools. While for more advanced simulations, like the ones you see in the automotive domain, we build 3D simulation tools on game engines.
On gaming engines, okay.
That's correct, yeah. So we are also seeing, in the industrial sector, such gaming engines are used, especially when you want to simulate how the factory in the 3D sense and want to see how the interface of the machines with humans look like, for example. So we use various simulation tools ranging from 1D tools like process simulation tools, which is comparable to any logic, for example, one of the popular tools out there in the market, to 3D tools like, Unity game engines.
Let's demystify a little bit this reinforcement learning approach. Can you explain me what is the next step when you have the simulation? What is happening then?
The next step in the reinforcement learning, once you build the virtual world, is basically let the model or the AI agent, how you call it, to learn in a trial and error manner from this virtual world what we built. So let's take an example here. So let's say we build a simulation of a factory with 5 machines that's producing one product. And now we build a simulation with the 5 machines and we let the AI models, number one, learn from the simulation, and number two, to make decisions within the simulation itself. For example, in the simulation, when the model is learning, let's say we break down one of the machines, one of the 5 machines. Then the model will learn as to what is the impact of this breakdown. So how does it impact the whole process? How does this impact the KPIs, for example, the cost, the volume, and the time of production? So that's one thing that it will learn. The second thing what the model does, which is unique to reinforcement learning, is it takes actions as control measures. So it's going to say okay, in case I have 3 machines that break down, then, let me try and fix machine 2 first and see if this makes the situation better. And based on the action it takes, it will understand if it was a good action or a bad action. Because typically in a reinforcement learning methodology, you have what you call as a reward and a penalty. If the action that the model took, for example, fixing the right machine at the right time, was a good action, then it gets a higher reward. But if it suggested to fix a wrong machine, then it will get a penalty. So in that sense, the model learns by doing a lot of mistakes, all in simulations. And then at some point, let's say after a lot of iterations of learning, it knows and it understands what is the right action it has to take. This is typically how we humans learn as well, like trial and error process, exactly. And this is the same principle behind building of this AlphaGo game from Google as well. So that's how the model learns in the simulations.
Okay, now I have the model. How do I integrate the model into my MES system, in my processes, in my IT infrastructure?
That's a huge challenge, to be honest.
Yeah, that's the biggest challenge, I think.
There's no real homogeneity or consistency in this in the industry at all. And to be honest, we are purely customer driven on this. So, for our models to work well, we need some data. For example, we need somebody to tell every day that, okay, today my order demand increased by 10%. So this could come from an ERP system where, and in the ERP tool, they could say that, okay, I want to increase my orders by 10%. So in that case, when our tool is integrated into ERP system, we automatically pick up the data and we give the plan back into the ERP system. While on the MES side, it's more on the planning side, where you know the state of the machines, what machines are there. And then we get this data from the MES tool in general, and then we keep this optimal solution back to the MES tool. So in both of these cases, our customers use the similar interfaces, what they're aware of, but we just go as a plugin in the backend into these tools. So they don't really, interact directly with the tool, but through the interfaces they interact with, among AI model. But nevertheless, we understand that a lot of customers out there, especially, in the SME and the mid-cap segments, they don't even have these ERP systems, right? And that is why we have built a unique UX for them, to which, it's just like how they use a normal software. They come into the software, just enter some values, and based on that, they will, get the optimal solution. And that's independent of any ERP or MES tools.
When you talk to your customer and you need to convince this Mittelstand CEO, what are your arguments and what is the USP of Phantasma regarding two other companies doing a little bit nearly the same?
Absolutely. And this is where we really stand out quite uniquely. And I believe there are just 3-4 companies in the whole world in similar state. So the biggest USP for our customers is that, we help them to make optimal decisions with AI without the need of big data. And that is the biggest USP. And when our customers compare our solutions with other solutions out there in the market, we are quite different because, first of all, we can save a lot of money for customers because otherwise, if you don't use reinforcement learning-based approaches, you have to ask your customer to collect data for 1 year, 2 years, and then give you the data, which you use for training. And end of that, they get the model that they can use for optimization. So you're talking about investments of about at least, in order of a few millions over 2-3 years, and also waiting for 2 years to get enough data to train models. So we, through our technology, are making this happen in less than 3 months. But this means that, the customers can see the return on investment in the time frame of, 2 to 3 quarters, which is important for managements to make decisions, right? When you typically with AI solutions, the challenge is that, the ROI you see is in 3 years or 4 years because of the data collection, model building, and, you don't see the ROI that quickly. But our goal is to give them the ROI in 3 to 4 quarters max.
I think reinforcement learning is a little bit hyped in the moment, and I'm not fully convinced by the technology. What are the biggest obstacles for you or for your approach in this factory environment? Because I think the factory is changing a lot during one day. Can you really build a simulation on this?
The biggest obstacle is, still, let's say, lack of, the base information we need to build simulations. Sometimes we ask factories, as I mentioned, the data snapshot saying how this factory looks like. But sometimes they don't have this in a format that we can use. So we have to help them and sit with them to understand how does the factory look like, what machines they have, what are the parameters within these machines. One example is some factories don't have a good way of logging their operators and the staff, for example. So they have a very rudimentary way of doing this. So a lot of this work goes into conversion of this information, which is there in a discrete way, into a way in which we can use. That's number one. And the second thing is that it's really to help them to understand that there are very small subset of use cases that reinforcement learning can solve. So typically when we go to our customers and tell them that, hey, we have an AI-based forecast, prediction and optimization tool, they kind of go into all possible use cases under the sun. For example, predictive maintenance, price forecasting is one of the use cases that's quite often we hear now. So the struggle here is to kind of help them to narrow down to the most relevant use cases that RL can solve and also can deliver value to them. So in that sense, for customer, they really don't get the big difference between RL and, supervised learning methodologies, for instance. So that's why, when you tell them that you can do this without big data, they are either doubting you or they believe that they're not the right customer for that.
When I visit Mittelstand, mid-sized companies, and you mentioned, for example, Audi as a partner or a customer of your solution, and I look at the production there, it's not that smart factory, multi-flexible, lot size, one production we see in the newspapers and the magazines. How difficult is it to use a reinforcement approach in these kind of factories?
It is indeed challenging to use any kind of AI methodology for this kind of factory. But what we do is you have to make some assumptions, right? So, for example, if you think about, let's say, Audi or similar factories, they have machines that are running there for 20 years. And typical lifetime of such machines are, 30 years, 40 years. And they're not going to replace this machine just for the sake of getting data. They're not just going to replace this machine just for, making digital. So in such scenarios, the way to go about is to make some assumptions with discussions with the customer, saying that, okay, you have this old machine that's part of this whole big factory, which is super old. We don't know how this works. We don't have any data insights about this. But how about we make some assumptions? So how long does this machine work? How long does it go into maintenance? And, what kind of operators are working on these machines? So this kind of assumptions would help us to, get into the first stage, which is building simulations, which is like the base for reinforcement learning. And of course, the solution, what we would recommend from the model itself, because of the assumptions, is not going to be 100% accurate. That's for sure. But still, there's so much value we can deliver to these factories, even by suggesting something that's 60%, 70% accurate, because without that, they would end up making either no decisions or bad decisions. So that's the approach we have towards, let's say, really classical factories that have digitalization to a very low degree.
And when we go into a smart factory, as you mentioned it, this smart factory is multi-flexible. Tomorrow I produce product 1. Next day I produce product C, D, E, F, G. How adaptable is your model when the factory is changing itself during one night or one day? How adaptable is the model in these situations?
That's a very good question. So first of all, we have to distinguish what is the change we're talking about here. So if you're talking about, let's say, changing the process flow of the assembly line, for example, putting in a new machine or, changing the flow of the product from A to Z, then this is something that the model doesn't learn automatically, because this is kind of going to the area of generalization, right? It's very difficult to have a model that generalizes to any scenario that can happen within the factory. So that kind of change, typically you have to do a bit of retraining, although it's let's say 20% retraining you have to do. And then the model is ready to be used. But if you're talking about changes that happen every day, which are, let's say, more or less parametrical changes, for example, machine going for breakdown, for example, or raw materials changing in terms of quantities, staff changing in terms of, number of staff available, for example. So this is something that the model is trained for. It can adapt to this in that instant, because this is not like changing the base of the model itself, but it's just like changing the parameters that are within this model. So typically, a lot of our, customers that we work with, they have their process flow assembly line fixed for a very long time, because they make this, in the context of, the whole product strategy and the factory setting up strategy. But what is changing in between, pretty much on a daily basis or even on a weekly basis sometimes, is saying, okay, I have shortage of raw materials, my buffer is depleting, or my staff is constrained. So that's those kind of changes we can take in the instantaneous moment.
Rama, how long does it take from the start point, from the project to the model on my shop floor?
Very good question. So a lot of different timelines here, depending on the customer. But I would say anywhere between 3 months to 6 months is the timeline that we have seen with the projects. The factors included here are, the complexity of the factory itself, like how many processes, how many variables are included within this. For some factories, they're like saying, look, our goal is to just reach the volume targets that we have from our clients at any cost. But for other factories, they have a multi-objective optimization problem. They want to reach the volume targets, but they want to keep the energy costs low. They want to keep the emissions low. They want to reduce the cost of production in itself. So for such use cases, we need a bit more training time because this contracting objectives.
And one more question, what does a client need to bring to the table in order to start? When I'm a Mittelstand CEO coming to you to Berlin, what do I need?
First of all, they need to tell us what's the vision they have. What are they trying to achieve with this kind of technology?
So you are the magician then.
At least we can help them to, go ahead and get more, smart in their decision. So we sit with them and we understand, okay, what are the KPIs that you want to improve in the next 2 to 3 quarters? And based on that, we identify, let's say, the most challenging use case. So for some factories, it's like very EDIs for one of the products that they're not able to handle on a daily basis. That's one use case. Other factories, it's maintenance planning, for example. And once we decide on the use case and what KPIs they want to improve, we ask them for, let's say, a basic set of information. So that's the data snapshot saying, okay, just give us information of your factories as of today. And then you understand how is their IT infrastructure. For example, if they have ERP tools, any tools. If not, how else would they prefer to use a product? And that's why we go ahead, we build the models, we ship the models, and then we show them an order of improvement in the KPIs through which they can already see that the model is delivering smart decisions and saving cost or whatever KPI they have.
So what are the next steps for you and your company in the next, I think, 3 or 4 months? You have to change your website, I think, because there are also a lot of automotive use cases.
Absolutely.
But what are the technical next steps?
So the technical next steps is to really building something that a lot of customers can use at scale. So this is the giant within AI, right? I mean, you could build something that's so unique to one customer, but it doesn't apply to the customer. But our goal is to take this technology to all the customers in the SME and the mid-cap segment, especially in Germany. And this means that we need to sit with a lot of these customers, understand what is the repeating use case among all these customers, how do they intend to use these models, and build a product that they can use pretty much in a scalable way. And this also goes in the direction of understanding from our customers, okay, what are the most important pressing points or challenges, and how we can include these in the AI models, and so that the models can help them solve these challenges. So the vision what we have is that we want to reach out to, let's say, a number of understand and SME or even mid-cap companies the next few weeks and months, and show them the potential of the model, show them that they can achieve optimal solutions with AI, even if they don't have the fully digital infrastructure that would be needed for other AI methodologies. So to show them that this is possible, this is feasible, and this is something that's relevant for them as of today. And that is the biggest goal we have.
Rama, I wish you a lot of success, much success for your approaches in the next months. It was a pleasure to talk to you. Thank you very much, and greetings to Berlin.
Thank you so much, Robert, for having me. I'm looking forward to engaging with a lot of industry leaders in this domain. And our goal is to really make efficient factories for the whole world.
Thank you, Rama.
Thank you.